Hi, so today in this video we're going to be talking about 1015 chapter 2.6.1 Introduction to System of Linear Equations. And we'll just hop right into it. So when we're talking about systems of linear equations, there are a few things that we need to keep in mind. So there are, three different types of systems of equations. The first system are these two, when they're parallel lines that will never meet. This is an independent, and I think it's incomplete. One moment. An inconsistent system. So it's not dependent or independent. These are called a consistent system. And it's basically when you have zero solutions. That's why it's inconsistent, because you don't have any. And then there's these, which is an independent, so there's one solution. It's where they intersect. It's an independent solution. A consistent, independent solution. Consistent, independent solution. And then there's also these, where it's kind of hard to tell here, but these are just two of the same lines. They're the same line, and they are directly on top of each other. And this is a consistent dependent solution. And in this case, it basically would be all real numbers would be your solution. And then there would be no real numbers for these inconsistent systems. And then for this, it would be basically this coordinate pair. It's kind of hard to see on this one, but we'll say it's about like 1, 0. With that in mind, let's look at some of the questions we'll see in this chapter. So it wants us to select all true definitions of the solution to a linear system with two variables. So basically, when we're talking about a solution to a linear system with two variables, our solution needs to be a coordinate point. This could be a solution, but this is not the solution to any linear system. So this is not one, and this is not one. But the ordered pair that satisfies each equation of the system independently, and the point of the intersection for the two lines in the system is going to be your answer, your solution to the linear system. You'll need to give it either as a coordinate point as x comma y, or you could do x equals whatever it is, and then y equals whatever it is. This one, we want to see if we want to determine what type of a graph this is. And this is going to be a consistent independent solution, because number one, it only has one solution, and a dependent system would mean that they are the very same line, the two of the same lines. And an inconsistent system would be one that has zero answers, zero solution, no solutions. Now this one, we want to match the type of system of linear equations in two variables with the correct type of graph. So I'll give you a minute to think about which is which. So this one, it's hard to tell that there's two lines here, but this is going to be a consistent dependent solution, because it is two lines that are exactly the same, and so you have all real numbers. An inconsistent system is one that has zero solution, so it's going to be these two parallel lines, and a consistent independent system is going to be this one that has one solution, and it's where it intersects. Consider the three systems of linear equations in the two variables below. Examine the slope and y-intercepts of each system to determine the type of solutions to that system of equations. Now, with this, what you can do is you can sort of imagine the two graphs. For this one, we have 2x minus 4, so 1, 2, 3, 4 will go about here, and it's going up 2 over 1, up 2 over 1. This is what our first graph is going to look like, and then we have plus 4, 1, 2, 3, 4, and it's basically doing the same but going down now. So this is our graph. It has one unique solution right here where it intersects, and which means it's a consistent independent system. For the second one, we have the same slope, but different y-intercepts. So we know that's going to be a parallel line, right? So that means there's no solution. It's an inconsistent system. Now this one, these have exactly the same slope. They just wrote it, exactly the same slope, exactly the same y-intercept. They just wrote the slopes differently. 2.5 is exactly the same as 5/2. And so this has infinitely many solutions, and it is a consistent dependent system. This one is asking us to consider the following system of linear equations in two variables. And it says, is 7, 5 a solution of the system? And what we want to do is we want to plug in 7 and 5 for our x and our y. So negative 5 times 7 plus 3 times 5 equals negative 20. That will give us negative 35 plus 15. And negative 35 plus 15 is equal to negative 20. So 7, that is a solution for our top one. And then negative 7 times 7 minus 4 times 5 equals negative 69. This will give us negative 49 minus 20. And if you do that operation, you'll get negative 69. So the 0.75 is in fact a solution of the system. You basically want to make sure that that coordinate point makes the statement true for both of our equations. This one is telling us to consider the graph of a system of linear equations in two variables. And it's going to ask us which of the points labeled shows the solution to the system of equations. And we know that the solution is where they intersect, right? And it looks like D is the label of that point. So our answer would be D. Y equals negative x plus 5 and y equals x minus 3. And it wants us to graph this and place a dot indicating the solution to the system. I wrote this one down. Basically, you just need to graph both of these lines like we have in previous sections. But one thing that I notice is you need to make sure that you also put a dot where they are intersecting. So that basically covers this chapter. If you have any questions, please let me know, and I'll answer as soon as possible. Thank you. Have a good one.